So, good morning, good afternoon, students. Welcome to the Real Analysis live lectures. In yesterday's session, we have seen what is metric space, what is norm space, and open ball, what is closed ball in metric spaces, right?
Yes, sir.
Yes. So, just I will revise instead of one homework is remaining, so I will give that one. We already found open ball and closed ball in R2 with respect to these norms. Can you see the screen?
Yes, sir. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, with respect to these three different norms, we have already seen what is open ball with center 0 and radius 1. Okay, similarly, you can find or you can draw the graphs of the, let me write, in a, or consider M is equal to set of all xy belongs to R2 such that x greater than equal to 0 and y greater than equal to 0. For any z in M, define norm of z2 is equal to under root x square plus y square. So find, or instead of find, draw the graph of open ball B1 at 0 in M. Can you draw this? Now instead of R2, I have restricted my metric space to only which part of R2? If R2 is this one, x greater than equal to 0 and y greater than equal to 0 means only this part, right? Yeah. So in this, what will be the open ball with respect to this norm? That you have to find and draw the diagram. Okay. I think you using the definition you can do that. Okay, we can take this one, and next we will have the theorem. We'll state as a theorem. In a normed vector space, B naught BR at x is nothing but x plus BR at 0 and BR at 0 is nothing but R times B1 at 0. Where what is BR at x? What is BR at x? It is open ball with center x and radius r, right? So x plus brx is nothing but x plus y, such that y belongs to br at, this is 0, we will write br at 0 and r times b1 at 0 is nothing but, what will be this? R times B1 at 0 is nothing but set of all R times Y such that Y belongs to B1 at 0. Is that right?
Yes, sir. Yes.
So it is just, you can have this step. Okay, let me draw the diagram. So what BR at X, suppose this is 1, 2, 3, minus 1, minus 2, minus 3. And this is 0, our origin. So if suppose center is 0, let me draw one ball. Take radius 1 and center at 3. Red color. Okay. What will be that open ball? What will be is B1 at 3. What will be that? It will be a ball like this with radius 1, center 3. Right? In R2, instead of V, I am now, this is for general. This theorem is for general metric, general vector space. Now, instead of that, I am just taking one example in R2, how it will be, how this theorem can be stated, okay? If I take B1 at 3, X is 3, R is equal to 1, what will be this? This should be as per 3 plus B1 at 0, right?
Yes, ma'am.
Yeah. So what is B1 at 0? B1 at 0 will be like this ball
1, 2, 3.
passing through this. Okay. So if I add 3 to this, so this point will move to this, right? This point will move to this. So this all points will move to this, like that. So this ball will be shifted to the here, this position. Are you getting this?
Yes, ma'am.
Yeah. So that is only this is in R2. And what is BR at 0? Radius is R, center is 0. So for this, how can I show you? Let us draw one. So this is 0, center 0, suppose, radius 1. So what will be B2 at 0 then? If this is 1, radius is 1, what will be B2 at 0? 2 times B1 at 0?
Yes, ma'am.
So it will be just shifted to here, like 2 times B1 at 0. If R is less than 1, then it will be, if it is half, then it will be like this. Okay. Are you getting this?
Yes, ma'am.
Yes, ma'am.
Yes. So just we want to prove this. It is very easy. Okay, proof. First we will show that or claim what is BR at X is equal to X plus B1 X plus BR at 0. We want to show. So we want to show this. First we show this. So for this, what is my claim? This is one set, this is another set. Okay. this one is one set, this one is another set. When we say that two sets are equal,
Elements
elements
equal.
are equal. But how, when we say that A is equal to B, if A is, means how we will show that one? A is subset of B and B is subset of A. Then we say that they are equal. So first we will show that BR at X is contained in X plus BR at 0, and secondly we will show that X plus BR at X is contained in BR at X, and then we can say that both sets are equal. So let Y belongs to BR at X. So what this implies? Norm of Y minus X is strictly less than R. This is open ball definition, right?
Yes, ma'am.
So I want to I have started with arbitrary element in BR at X, and I want to show now that Y also belongs to this set X plus BR at 0. Okay. So let Z is equal to Y minus X. So what this gives? Norm of Z is less than R. Norm of Z is less than R.
Yes, ma'am.
Okay, or let me write here. Norm of Z is nothing but norm of Y minus X, and which is less than R. So what this implies? Z belongs to where? Z belongs to which ball? BR at X, right? But what is Z? Z is nothing but Y minus X. Okay. So Y minus Z belongs to BR at X. Let me, not Z belongs to BR at X. Y belongs to BR at X means norm of Y minus X is less than R, but like this. Okay. Norm of Z is strictly less than R. Means what is center here? Radius is R. What is center? Z minus 0. So what will be that ball? BR at 0. So this implies Y is equal to X plus Z, where Z belongs to, that means it belongs to X plus BR at 0, right? Are you getting this?
Yes, ma'am.
So this implies we have started with BR at X. BR at X is contained in X plus BR at 0. You can give number 1 to this. Now to prove other way, X plus BR at 0 is containing BR at X. So start with element from X plus BR at 0. So let Y belongs to X plus BR at 0. So what this implies?
Norm Y minus X.
Y is equal to X plus Z, where Z belongs to BR at 0, right? This implies Z belongs, what is norm Z? Z belongs to this open ball. So what should be norm Z? Less than R?
Yes.
Yes.
Yes, ma'am.
Less than R. So this implies norm of Y minus X is less than R. So this implies Y belongs to where? Y belongs to where?
BR.
BR at X. So this implies X plus BR at 0 is contained in BR at X. Give number 2. So from 1 and 2, 1 and 2, x plus br at 0, or br at x is nothing but this one. Br at x can be written as x plus br at 0. Similarly, we can prove, now to prove, what we want to prove? Br at, what is now remaining to prove? Br at 0 is Br at 0 is nothing but r times b1 at 0. So same thing you can apply. So let y belongs to br at 0. What this implies? First we will show br at 0 is contained in r times b1 at 0, and then r times b1 at 0 is contained in br at 0. Okay. So y belongs to br at 0. What this means?
Norm of y.
Norm of y, or I will write below. This implies norm of y is strictly less than r. So this implies norm of y by r is strictly less than 1.
Yes, ma'am.
R divided by r on both sides. R is scalar, right? R is scalar, so norm of y by r will be less than 1. Are you getting this?
Yes, ma'am. Yes, ma'am.
So what can I say?
Y by r belongs to br of m.
This, or I 1 by r times this implies y by r belongs to b1 at 0. That means y belongs to r times b1 at 0. So what this gives? So this implies, instead of that, I will write here only, br at 0 is contained in r times b1 at 0. Give number 3 to this. Similarly, now to show r times b1 at 0 is contained in br at 0. So how can we show this? Let y belongs to r times b1 at 0. So what will be, this implies y is equal to r times z, where z belongs to where? b1 at 0. That is, or this implies z belongs to b1 at 0. But then what is norm? Let me write properly. What this implies? Norm of y is equal to norm of r times z. But what is norm of z?
Less than. Less equal.
Less than? I can write less than r because norm of z is less than 1, right? This implies y belongs to br at 0. b1 at 0. Is that okay? So from 3 and 4,
Yes, ma'am.
R times or BR at 0 is nothing but R times B1 at 0. Is that okay?
Yes, ma'am.
So now we will start. Now next convergence in metric space. Okay, for that I will require some definitions. Bounded set again. We have already defined bounded set, but we have defined in real, on reals only. Okay, now we have to define what is mean by a bounded set in a metric space. So let MD be a metric space. What is bounded set in real line? We already defined.
There exists case such as less than
A is
k
said to be
for R
bounded set in R if
there exists
there exists M such that mod of X is less than or equal to M for every X in that set, right?
Yes,
So now instead of now R, particular R, we will have general metric space and we will define a bounded set. A subset, a set A in M is said to be bounded if A is contained in some open ball. A is contained in some open ball, that is, there exists X belongs to M such that, what can I say? There exists X belongs to M and R greater than 0 such that what? A is contained in BR at X, some open ball, right? Are you getting this? M is any metric space, then if there exists some X belongs to M and R greater than 0 such that A is totally contained in that BR at X, then we will say that A is a bounded set. Is that okay?
yes, ma'am.
Yeah, now take next definition. Diameter of a set. Diameter of a set for a subset A of M, the diameter of A, what should be diameter? Is denoted by DIAM of A and is given by, diameter will be what? तुम्ही बॉलचा डायमीटर किंवा सर्कलचा डायमीटर कसं डिफाइन करता? 2 times radius. Okay. Instead of that, suppose this is ball. This is your ball. What is diameter? Diameter is this one.
Yes, ma'am.
It is supremum of distance between any 2 points of that set. So diameter of A is nothing but supremum taken over distance between any two elements of that set where A and B belongs to A, right? Write this off properly. Okay. Now again, we have defined bounded set as well as diameter of A. So from this, we can say that remark we can say, or theorem, theorem we can prove as a theorem. Theorem, a subset A of M is bounded if and only if diameter of A is finite. Can you, so suppose A is bounded. Suppose A is bounded. Then there exists X belongs to M and R greater than 0 such that A is totally contained in BR at X. So now let any 2 points AB belongs to A. Okay. What this implies? Distance between AB, distance, or if A and B belongs to A, what can I say about AB? A and B also belongs to BR at X.
Yes, ma'am.
A comma B, these points also belongs to BR at X. So what should be distance between this implies? Distance between A and X. What should be distance between A and X? It should be less than R. And distance between B and X is also less than R by definition.
Yes.
So what this implies? Distance of AX plus distance of BX is nothing but distance of AX plus distance of XB, right? Which is nothing but, which should be less than, what is distance between AX is less than R and
distance of A comma B.
Yeah. So which is less than R plus R, right? Which is nothing but 2R. So I can write here distance between AB is nothing but distance between AB is nothing but distance between AX plus distance between BX. Okay, this only we can XB, which is 2R. So if I take supremum over all elements, distance of AB, which will be nothing but AB belongs to, supremum is taken over all elements of A, which is less than 2 times R. So what this implies? Diameter of A must be finite, right?
Yes, ma'am.
Because it is 2 times R means it is finite. Okay. Now conversely, suppose diameter of A is finite. And that is diameter of A is less than infinity, or we can say which is equal to RC, we will say. diameter of A is finite, which is equal to R say. Okay, so if diameter of A is finite, then what can I say? I want to show now A is bounded. I want to show now A is contained in some open ball. Diameter of A, I am saying R. So can you give me a ball in which A is totally contained in?
B R by 2 of x.
Let x belongs to A. Let x belongs to A. So what is my claim? I want to show A is contained in B 2R at x. Can I say this? Diameter of A is R.
So radius is R by 2.
Radius. So if I take any ball with center x and radius 2 times r, then every element of A is contained in this ball.
Yes.
Yeah. Let y belongs to A. Now since x and y belongs to A, what is distance between x, y? It must be less than equal to diameter of A, which is nothing but r. So this implies distance between x, y is less than equal to r, and which is strictly less than 2 times r. I want open ball, so I am taking 2 times r. Okay. So what this means? Y belongs to where? Y belongs to B 2r at x. Means this implies A is contained in B 2r at x. So A is bounded. Therefore, A is bounded. Is that okay?
Yes, ma'am.
Now we define, we have already defined convergence in real line. Okay, so now we will define convergence in metric space. Convergence in metric space. We say, or directly definition we will write. Let MD be a metric space. A sequence xn in M is said to be converges to x belongs to M if, what is definition for real line? When we say that xn converges to x, mod of, not only mod, but for every epsilon greater than 0, there exists natural number such that mod of xn minus x is less than epsilon. Now here instead of mod, what will be? What should be there? If for given epsilon greater than 0, there exists natural number n belongs to n such that distance between xn and x is less than epsilon for all n greater than equal to this capital N. Is that right?
Yes,
So if that metric space is if that metric is modulus, then here D will be replaced by modulus, right? So distance, how metric is defined on a set, like that definition will change only. Okay. Similarly, what is Cauchy sequence?
Xn y Xn.
Definition: Xn is said to be, let MD be a sequence, let MD be a metric space, a sequence Xn in M is said to be Cauchy. Can you tell me if for
Distance of
every epsilon greater than, for every epsilon greater than 0, there exists n belongs to n such that distance between xn and xm must be less than epsilon for all n m greater than n. Is that right? You take capital N or small n0, no problem. Is that okay?
yes, ma'am.
This is Cauchy sequence in metric space. Now we state a theorem. Let MD be a metric space. Then every convergent sequence is Cauchy, but converse need not be true. Converse need not be true. True. Need not be true means every Cauchy sequence need not be convergent. Okay. So in real line, we already proved that every convergent sequence of real numbers is Cauchy and every Cauchy sequence of real numbers is convergent. Already we have shown, right? Can you recall it? In real line, already we have proved that every convergent sequence is Cauchy and every Cauchy sequence is convergent. But in general metric space, every convergent sequence is Cauchy, but converse is not true. Okay, so we have to prove it. Proof. So let Xn be a convergent sequence. That is, Xn converges to X for some X belongs to M. And what we want to show? What do we want to show? We want to show it is a Cauchy sequence, right? Now we want to show Xn is Cauchy. Claim Xn is Cauchy. So to show Xn is Cauchy, we have to show that for every epsilon greater than 0, there exists natural number such that distance of Xn Xm is less than epsilon. Okay, so start with epsilon greater than 0. Okay, so let epsilon greater than 0. Since xn is Cauchy, xn is convergent, what can I say? There exists n belongs to natural number n such that what? Distance between xn comma x is less than epsilon for all n greater than equal to n, right? So let n and m greater than equal to n. Consider distance between xn and xm. How I can write this? I can use triangle inequality x and x plus distance between x and xm. Can I write like this?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Not equal, it is less than or equal to, okay? Distance between x and xm is nothing but less than equal to distance between x and x plus x and using, we can say here, using triangle inequality. Inequality. What can I say? This is less than epsilon. This is also less than epsilon, right? For all n greater than equal to n, distance between x and x is less than epsilon. So instead of this, I will write here epsilon by 2, epsilon by 2. Can I write like this? Which is nothing but
Yes, ma'am.
epsilon. So this gives me, this implies xn is a Cauchy sequence. Now I want to show converse is not true. Converse is not true in general. So if I want to show converse is not true, means I want to give some example of a metric space in which it is not, in which a sequence is Cauchy but not convergent. Okay, I want to give a example of a sequence which is Cauchy but not convergent. So consider xn is equal to 1 by n. In metric space, in MD metric space, I will take as open interval 0 closed 1, and with distance I will define as modulus. Can you show this is a Cauchy sequence? We will show this is a Cauchy but not convergent. What is limit of 1 by n? What is limit of 1 by n? Just a minute.
0.
Limit is 0, but 0 does not belong to this metric space. So this is not a convergent sequence, which is Cauchy but not, this is Cauchy but not convergent, as 0 doesn't, or as 0 does not belong to this metric space. Okay, you can easily prove this by using Archimedean property. In real line already we have proved this is a Cauchy sequence, right? So we will have a next theorem, or we will have a remark first, then we will go to next theorem. A remark: in a metric space, bounded sequences may not have a convergent subsequence. Convergent subsequence. In real line, if sequence is bounded, we know that it is convergent.
Yes, sir.
It will have a convergent subsequence, but in
Yes, sir.
general metric space, bounded sequence may not have a convergent subsequence. For example, let MD be a metric space. MD is equal to, say, R with discrete metric. R with discrete metric, and let xn is equal to n. Then this sequence is bounded. What can I say about this sequence? Whether it is bounded?
Yes, sir.
Why it is bounded? When I say that a sequence is bounded in metric space, if every element of that sequence is contained in some open ball. Can you give me an open ball of some radius, center and some radius? Sequence is 1, 2, 3, 4, 5, 6 and so on. I am saying xn is bounded. So if I want to say this is bounded, means I want to show this xn is contained in some open ball, right? So this set xn n greater than equal to 1, if that contain in some open ball, then I can say it is bounded. So which ball shall I take here? Can you give me a ball? Is that okay? B2 at 0?
Yes, sir.
What is x1? For this sequence, what is x1? x1 is 1, 2, 3, 4, 5 and so on. This is my sequence, right?
Yes, sir.
So I am saying it is contained in B2 at 0. When I will say it is, what is the distance between 1 and 0?
1. 1.
It is 1.
1.
D is a discrete metric. What is distance between 2 and 0? D is my discrete metric, okay? What is discrete metric? How discrete distance of xy?
is equal to 0 when x is
0 if
equal
x
to
is equal to y, and 1 if x is not equal to y. So when 2 is not equal to 0, what is distance? It is 1,
y.
right? What is distance between 3 and 0?
One.
It is 1. So which is less than 2. So it must
Yes,
contain in B2 at 0. Every element is member of this set B2 at 0,
Yes, ma'am.
right? So this xn is bounded sequence, but it does not have a convergent subsequence. Can you give a convergent subsequence for this? But
हॅलो मॅम
yes.
एडीएमचं लेक्चर सुरू झाले मॅम
As okay. Okay, we will stop here. Have a convergent subsequence. Okay, we can stop here and we will start whenever our lecture is there. Okay, next time. You can leave the meeting.